Okay, so our order is ERT. Here's an example of all the different ways that we would see reflections, expansions, compressions, translations, and all of that. When we have a 2 out front, it is a vertical expansion by a factor of 2. That's a lot of English language that I do not want to write. We're going to call this a VE, vertical expansion, and the number will tell me by how much. When I see a 1/5, that is a vertical compression. We are getting smaller by, oops, not a 5 at the bottom, or sorry, 2 should be a 5, because there's a 5 here. Okay, and similarly, when we do the horizontal stuff, right, this is going to be a horizontal expansion by 2, a horizontal compression by 1/5. Remember that when we are dealing with stuff inside and next to the x's, it is usually the opposite of what we see. These are our expansions or stretches. Deal with them for stretches. All right. Then when we do reflections, we see a negative on the outside. This is a reflection over the y-axis. I'm going to use the letter R for reflection. And you can say R over X or R over Y. We're going to deal with this tomorrow, so don't worry about it for right now. Or you could say, if it's over the X, it's upside down. So you can say UD, although up, down might be confusing. So I prefer this method. You can call this one backward or back. These represent your R's. And lastly, your translations. If you see a plus minus on the outside of the function, this translates to the vertical stuff. So this is up 3, down 5, right 3, left 5. So we're going to use UD for up, down, RL for left, right. These are our translations. And this is the order we're going to do them in every single time. Okay. Now, let's take a look at some examples. One of the things you got to be mindful of is making sure that we always have our equations written in this form, meaning that if there's ever something in front of the x, we need to factor it out so that the x has a positive 1 in front of it and everything else gets pulled out. So looking here, we're going to make a list of the reflections, or sorry, transformations here. I see 3 numbers, so there are 3 things happening. Can we shout out what is happening in this transformation? VE2. Next. R4. Next. Up 5. So there are 3 things happening on this graph. So when I write my coordinate mapping, x, y, it's going to look like this. X plus 4, 2y plus 5. And now you can see why order matters. When we go to the y coordinate, if we did the plus 5 first, that wouldn't make sense, right? That doesn't follow the order of bed mass. We must do the multiplication stuff first and then do the adding and subtracting. So that's why ERT is important. Okay, B. What are we doing for B? Reflection over x-axis and a reflection over y-axis. So I'm just going to do plus y, so x and y. What else? HC 1/3, right? Because the 3 is next to the x. So then my mapping coordinates, I'm not going to keep writing xy. We all know the original points are xy. If we were mapping it, what would be my equation here? How would I write the new x coordinate? 1 over 3x or x over 3, yes? Almost. Negative where? In front of the x. How am I writing my second coordinate? Negative y. Done. Okay, so for the next few, I want you to be very careful about what is in front of the x. Here, I will have 1 over 4f. I'm going to make a square bracket for when I need to factor. I'm going to pull the 4 out so that the leading coefficient on the x is a 1. If I factor out the 4, what's left inside the bracket? X plus 2. Perfect. Now I can see what are all the transformations that are happening. So what would I write for C? What are the transformations? BC by 1/4. What else? They're not up to, but there is a 2 involved. Pardon? Left 2, yeah. There's one more thing. Right here. Say that louder. What's the 4 next to the x represent? It's going to be a horizontal compression or expansion?
Compression.
Compression because it's always the reciprocal with the x, yes. So then my mapping would be x over 4 for the compression, and then minus 2 for the shift, and then y over 4 for the vertical compression, and there's no up or down. So that would be my mapping. Okay, take a moment with your partner or whoever you're sitting next to, factor these first if applicable, and then make your list. Just do the list for now, and then we can write the mapping together. Take a moment, factor, and make a list. Make sure that x is always first in the bracket and that the coefficient is positive 1. I'm going to start making the list, and you can compare what you have to what I have. Oh, I don't need to factor that one there. Okay, I have just put up the corrected factored form of the transformations. Can you compare what you wrote to what I wrote? Do we agree? Do we understand? Do we have questions about how I got these answers in green? No questions how I got these? Yes, ma'am. Yes.
For the negative in front of the X.
Yes.
Can you put it in front of the X? What do you have to?
Oh, good question. Not in this case. The negative has to stay inside because this negative represents a reflection on the X. If I moved it to the outside, then the X would stay the same, and now I have a reflection in the Y. So I would be flipping it upside down instead of backwards, where this equation is telling me I have to flip it backwards. That's a good question. If the negative is in with the X, it stays with the X. So when you factor it out, it has to stay with the X. Any other questions about how I factored any of the equations? We're good. Okay, so if you wrote the correct list, you should then have the following mappings. Do the mappings make sense with what you wrote? So here, this would be a reflection over Y. Right 5, down 2. This is a reflection over Y. Expansion vertically by 5 and left 2. Horizontal expansion by 2, left 2. Vertical expansion, horizontal expansion, and a reflection over X and Y. Oh, and up 7. That last one had lots of them. Okay, so looking at the factored form of our equation, identifying where the positive negatives are for the reflections, identifying what the coefficients are for the expansion or compressions, and then what our translations are for left, right, up, or down. Okay, so the last thing we're going to do today is do some practice questions. So page 2 is pretty much what you're going to have on your quiz. Okay, so on page 2, you are given the original function. We don't know exactly what it is. It's f of x, but these are the original coordinates, x and y. What we then want to do is transform them, and here's 3 different transformations that we could do with the original function. We are going to do exactly what we did on the previous page. Identify what are the transformations, what is the mapping, and therefore what are the new coordinates. Okay, so the first one is hopefully an easy one. I can see a vertical expansion by 2 right there. I can see that I'm moving left 3 and down 2. So when I take my original coordinates x, y, and I transform them, this is going to be x minus 3, 2y minus 2. Is that a straightforward transformation? Do we need to go over it? Do we understand how I got those numbers? We're okay. Okay, so now what I'm going to do is you're going to take all of these x's and chuck them in there, and then put them there, and do the same for the y's. -4 minus 3 is -7. -2 minus 3, -5. 0 minus 3, -3. 5 minus 3, +2. All right, and same thing with the y's. Take the y's and put them into the transformed y. 6 times 2 is 12. 12 minus 2, 13. Oh, just kidding, it's 10. 0 times 2 is 0, so this is -2. 4 times 2 is 8. 8 minus 2 is 6. -2 times 2 is -4. Minus 2 is -6. So if you can identify the transformation, or identify the mapping, I can give you a graph. You're going to plot these points and essentially connect the dots. Done. Right? Okay, give these two a try. So remember, have it in factored form first. Identify what are, so you don't have to make this list if you don't want to. If you want to jump straight into the mapping, that's fine. But it's up to you. I'm going to write the coordinates so you can check your work if you did it correctly. Can someone check if my factoring matches your factoring? Did I do that correctly? Yes. Okay, so my list. I have a reflection over y. Horizontal compression, 1/2. I'm going to the right, 3. I'm going down, 3. So there's 4 things happening with this particular one. Negative, a 2, a 3, and a 3. So when I do the mapping for it, it's going to be -x because of the reflection, divided by 2 because of the compression, plus 3 because of the translation, and that's it. And then for y, it's just y minus 3. Okay, and in order to get these coordinates, again, I'm taking my original and putting it into my mapping. Once you have your mapping, you can put those points on a graph, connect the dots, and you're good to go. Okay, I'll give you another minute for the last one. You don't need to factor the last one, which is nice, but make sure your mapping is correct. Okay, once you're ready, you can look at the screen. Compare what you wrote with what I wrote. So if you understand the base function and how it works, y equals plus or minus a times the function plus or minus 1 over b x minus h plus k. We have reflections if a or b is negative. We have stretches if a and b are not 1. And we have translations if h and k are not 0. Okay, so you should be able to fill in the blanks or look at the equation and be able to figure out what's going on with the original graph. Okay, I'm going to hover over the screen for just 1 more minute. Double check your work. This is posted in our Teams too, so you can always go back and look at it if I'm going too fast. All right, our last example today is we are going to be transforming a graph not only by looking at the equation, we're going to list the transformations, we are going to make a mapping, and we're actually going to draw it. So let's go down to example 3 here. And it says, given the function f of x is absolute value x, list the transformations in the correct order, graph the function. So before we do any of that, this is the original. So let's first draw the original. What does an absolute value function look like? Can you tell me a point on the absolute value function? Give me a coordinate. Where does it start? If we're not sure, go back to, I think, page 2 in our notebook. We did this on the very first day. Kush? You have your hand up? Okay, page 2, absolute value means that x and y are the same number, but y is always positive, right? So if x is 0, y is 0. If x is 1, y is 1. 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. They are equal to each other. But if I go backward and I put a negative number in, -1, y is still always positive. But it goes up in increments of 1. And it looks like a V shape. I'm going to pick 3 key points to keep track of so that I don't have to make a really long list of values. And the first one I'm going to choose is 0, 0, because it's easy. And I'm also going to choose 6, 6, and -6, 6. That in the wrong spot. Let's do it here. Okay, I'm going to keep track of just 3 coordinates as I do my transformation so I can double check if my work is correct or not. So we have the original function. Here is my first transformation. First, I'm going to rewrite it in factored form. F square bracket 2 x minus 1. So the negative out front tells me I have a reflection over x, so it's going to be upside down. I have a horizontal compression by 1/2, so it's going to get skinnier. And I'm going to move to the right 1. Okay, so again, imagine your arms out above your head as if you were making the V. A horizontal compression means I'm bringing your arms closer together, right? We're squeezing it horizontally and we're flipping it upside down and we're moving it over 1. So that means when I do my mapping x, y, my x coordinates are going to be x divided by 2 plus 1. And my y's are just going to be -y. Okay, so now let us graph the transformed graph. Let's use my point 0, 0. If I put a 0 in the x, 0 divided by 2 is 0, plus 1 is 1. If I put a 0 for the y, it's still going to be 0. So this is going to be 1, 0. That's my vertex point. Right? Let's do this coordinate. If I put -6 in here, -6 over 2 is -3, plus 1 is going to be -3 plus 1 is -2. And if I put +6 into the y, this is going to just give me -6. So this coordinate is now at -2, 1, 2, -6, 1, 2, 3, 4, 5, 6. My vertex moved to 1, 0, and my 6, 6, where is it going to go? 6 divided by 2 is 3, plus 1 is 4, and -6. So 4, -6. Here is what my transformed function will look like, and it's going to go on forever. But those are my 3 key points. Now you can look at the original, look at the new one, and say, did I do this correctly? I said it's going to be flipped upside down, it's going to be squished, and moved to the right one. Does that picture accurately reflect what I said? Yes, it's skinny, it's upside down, it's moved to the right. So now I've done this correctly, move on. Okay, so I'm going to do exactly the same thing. I'm not going to redraw my original graph, but we're going to keep it there with the original 3 points that we're going to worry about. But let's take a look at what we're going to do here. I don't need to factor it, which is nice. This is going to give me a vertical compression by 2/3. I'm going to go to the right 4 and up 3. So from my original xy's, I'm going to have x plus 4, 2y over 3 plus 3. That is my mapped coordinates. So now I'm going to take my values here, and what are my 3 points going to look like? Let's start with 0, 0, because it's always the easiest one. If I put 0 in here, I'm going to get 4 and 3. That's my new vertex. 4, 3. 1, 2, 3, 4. 1, 2, 3. If I take -6, 6, -6 in here, that's going to give me -2, and -6 in, or sorry, +6 in here, 12 divided by 3 is 4, plus 3 is 7. So -2, 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. -2, 7 is my new coordinate. Okay, and then +6, 6 is going to give me +10. And 7. So +10, 7 is over here. So this is my new transformed V. And before I move on, I have to ask myself, does it make sense? Vertical compression means I squished it down to the right 3 and moved it up 3. Does the picture match what I said it was going to do? Yes. Okay, so I did that one correctly. Can you take a moment? Do this one on your own. So write down what are the transformations? Make a map or a mapped coordinates, and then use our key points: 6, 6, 0, 0, -6, 6. Okay. So I have a vertical expansion by 3, which means I'm a bit off the charts here. So my y values are getting multiplied by 3. I have a reflection over the y-axis, means I'm flipping it backwards. But because I haven't moved left and right and it's symmetric, it doesn't look like I flipped it backwards, but I did. And I have divided the x values by 2, means I've squished it in. I've squeezed it in horizontally and I've stretched it up vertically. And if we look back at what the original function looks like, squeezed in, stretched up, we've done that correctly. Okay, so this is all for lesson 5. Your homework. I'm going to make a note of it here. Section 1.3 in the textbook. That's pages 38 to, what did I say? It was a 38 to 41. And or Delta Math under the mixed transformations assignment has lots of good quiz questions on there. Oops. Transformations, I think it's called mixed. And there might be a level 1, level 2. Always strive to get up to level 2. Okay, so one question on your quiz. All right, you're going to see a graph. Here is the original. Here is the new one. You are going to fill in the blanks. F bracket, X bracket. You're going to tell me what's the A, what's the B, what's the H, what's the K. Okay, in question 2, I'm going to give you y equals f of x, y equals a transformed f of x. I'm going to give you a graph and you are going to draw it. So essentially it's going to look like this, right? Where you know the original, you know the transformed, at least the equations, and you have to be able to draw both. Okay, so from a picture, can you create an equation? From an equation, can you create a picture?